Suppose I didn't want to look at that table every time I wanted to decide whether my clothing matched. I can build a circuit, and I can build a circuit using logic gates and switches and light bulbs. And here's how to do it. And I have a logic table, and what I do is I suppose that I have a bunch of switches, I have a bunch of logic gates, and I have a light bulb. And what I did was I figured out how to wire those things together so that I could flip switches corresponding to the color of my shirt, shoes, pants, and socks, and then decide whether it matches just by looking at a light bulb. If light bulb was lit, then I knew it was matching. If it wasn't lit, then I knew it did not match. And this is a picture of that circuit. We have a light switch here, and this is a special kind of light switch such that when the light switch is up, as are all four of these, when the light switch is up, that means that the switch is off. There's no power going out of it. And so here's an example where I have the light switch flipped up in all four cases, which means all switches are off, and that means I've selected all black clothing. Up on the switch means black, and down means brown. And I've wired together some logic gates. So there's four inputs corresponding to these four switches, and these four inputs are split among two logic gates. They're combined to another logic gate, an AND gate, and then the output goes to a light bulb. And what I've done here is I've sort of guessed what combinations of logic gates that I need to do to implement that logic table on the previous slide. And there's a program that we'll use later in class that I just showed you a screenshot of that allows you to experiment with logic gates. And for you, you'll be able to verify whether or not that this table is actually represented accurately by this configuration of logic gates. And you would do that by looking at each row of this table and flipping the switches, the input switches, according to the state of each column, 0, 1, 0, 1. So you would have half of the switches up, half of them down, and then to figure out if you got the right answer, you would say, this row has 0, therefore I expect the light bulb to be off. And again, what's shown in this table here is corresponding to the top row, all black, all zeros for the input, and it matches. And what's shown here is corresponding to the bottom row of the table, all brown, and it matches.